Welcome, everyone. So next up, we have Esther Nam speaking on one weird trick to becoming a better software developer. Let's help welcome her.
Okay. All right. Thank you all for coming. I'm here because I would like to be a great developer someday. I've been a software developer now for about 7 years, and in my relatively short career, I've worked at a number of companies. And between work, the SoCal Python meetup I helped to run, and coming to conferences like PyCon, I've had the good fortune of knowing at least a few developers whom I'd consider great. I've been trying to figure out what they have in common because I don't believe that developer greatness is a fixed trait. I take the growth mindset and believe that by working hard and practicing the right habits, I too can achieve greatness. But what exactly do I mean by a great developer? I'll explain by way of a few illustrations. Meet Goofus. Goofus is a developer who's been working at Acme Widget Co. for 6 months. She nailed her whiteboard interview with the most elegantly written algorithms the team had ever seen. Her first project involved building a slingshot prediction machine, and she was excited because she'd built something similar at her previous job, so she knew exactly how the machine should be designed. Goofus worked really hard for 2 weeks, but when she was finished, the product manager found that Goofus had made some assumptions about the specs that weren't quite correct. Goofus worked hard without complaint to make every change, but the project ended up taking several weeks longer than expected. Goofus has a coworker named Gallant. Gallant has been working at Acme for only a little longer than Goofus has, but Gallant already has a process in place for new projects. She sets up a very short daily meeting with the designer and QA lead so that they can give and receive feedback on features and change requests right away. One day, Gallant went to lunch with the company's marketing analyst, who mentioned that a part that Gallant was building could be useful for another company project by adding some tracking. Gallant found she could easily add tracking within the current project scope, and this offhand feature request ended up doubling Acme Widget Company's revenue for the year. A final story. Goofus was tasked with developing an internal tool, leading 2 junior developers on the project. Goofus was excited at the chance to teach the newbies how to code as well as she did, and designed a framework that was really elegant and efficient. However, the junior developers had trouble even setting up their development environments in a way that let them start working on the project. Soon, the junior developers stopped going to Goofus with more of their dumb questions. Instead, they started going to Gallant for help. Because Goofus had been too busy with optimizations and test cases to write any docs, Gallant had to message Goofus constantly for more clarification on the architecture. Both senior developers ended up spending way too much time helping the junior developers on the project, and the delivery date went further past the original deadline. And even worse, Gallant had trouble meeting her own deadline on her own project because she'd been so busy helping out the others. These stories are greatly exaggerated, but I bet most of you have seen or experienced similar situations in your own jobs. What are the qualities of developers like Gallant that set them apart from developers like Goofus? Well, most of us tend to think first of technical ability when it comes to developer greatness. This is from Stack Overflow's annual survey with responses from around 64,000 developers in 2017. It can't be denied, great developers must have a solid foundation of technical skills. Also, great developers ship the right project at the right time. Often, the emphasis is on the on-time part, but the right product is just as important. There's no point in writing software with perfect code and 100% test coverage if nobody ends up using the darn thing. Now, you may or may not find the top trait surprising. And one metric that's not on here that I always come back to is, if I worked with someone like Gallant and they told me they were leaving the company, would I consider following them? How many of the other developers would feel the same way? Why do we want to work with great developers? Well, they make good software. They help us become better developers because we learn so much from them. They make our jobs easier, and maybe even more fun. We software developers usually work as part of a team. So thinking about the QA person testing our software, or the DevOps person helping us package up our code to deploy to prod, or the product manager who wants to show off cool new features to the company clients, If we code with their needs in mind, we'll be the developer everyone wants to work with. And it turns out, empathy skills are what help great developers be so great. So let's talk about this one weird thing called empathy. First, let's make sure we all understand what empathy is. Here's a simple definition that I like. Empathy is the experience of understanding another person's condition from their perspective. You place yourself in their shoes and feel what they are feeling. Empathy is marked by a distinction between oneself and another. There are two types of empathy. One is emotional empathy, which is not just about feeling compassion or being nice. For example, if your coworker is upset because they're hungry and this meeting you're all in is running late, you may feel sorry for them. That's sympathy. But if you feel their hunger, or you remember yourself being hungry in long meetings, and it moves you to take action to help your coworker, maybe you'll sneak them a snack, or suggest out loud that we cut the meeting a little short, you're feeling empathy. There's also cognitive empathy, which is the ability to understand something from the perspective of another. Cognitive empathy is tied to the concept of theory of mind, which is the understanding that others have mental states that differ from one's own. And it's not just enough to imagine yourself in others' shoes, because what if your assumptions about the other's perspective are all wrong? To use a trivial example, you are a Slack power user. So whenever you need to ask a coworker something or to give them a heads up about some kind of change, you fire up Slack and you shoot them a message and you go your merry way. But if you really wanted to make sure your coworker got your message, you might take a second to check first. Does this coworker use Slack the way I do? Or do they prefer email or even a face-to-face interaction? Assuming they would want what you yourself prefer would not be the most empathic choice. You should instead make an effort to learn what their preference actually is. If you don't truly take another's perspective, what you're really doing is called projection, rather than empathy. You've heard the golden rule, do to others what you'd have them do to you. But the golden rule isn't about what you do. Putting yourself in someone else's shoes means fully imagining yourself as that person. You treat them as they would want to be treated, rather than the way you yourself would like to be treated. While the two types of empathy are related to each other, cognitive empathy activates different areas of the brain from emotional empathy. A deficit in one doesn't necessarily mean a deficit in the other. Regardless, empathy isn't easy for most of us. It requires effort, a lot of patience, and a certain imaginative ability for us to place ourselves in somebody else's shoes, especially if the other person is dissimilar or unfamiliar to us. Yet empathy is often seen as merely a soft skill. We tend to undervalue soft skills in tech. And so you may believe for this reason or another that empathy is not worth the effort to practice. But I don't think that's true. If our brains can learn how to write complex algorithms or cook up layer upon layer of abstraction over a set of arbitrary business rules, why couldn't we also learn to get better at seeing what others see or feeling what they feel to do our jobs better? Also, research has shown that soft skills are surprisingly important for building productive, successful teams. Microsoft recently released a paper entitled, "What Makes a Great Software Engineer?" They claim to have identified 53 attributes of great developers, but thoughtfully provide a much shorter summary, which I'm going to quote here. There's a lot of good stuff, but what I want to emphasize is the last bit, the part in red, which I mentioned resonates with me. So, how do we practice empathy to get better at understanding how others think and feel? I've got 5 ideas relating mostly to cognitive empathy. They may not all work out for every one of you, but I hope everyone finds that at least one of the suggestions works for them. I'm going to start by suggesting one baby step, where the other in the self-other distinction I described earlier is actually still you. So, how many of you have looked at some code that you found absolutely unreadable? You ran git blame and discovered that the terrible coder was in fact yourself. Right? This is code you'd written a year ago, but it's almost as though somebody else entirely had written it, someone stupider. The problem is not that past you is actually stupid, it's because past you had a completely different set of knowledge, assumptions, and context from which they were working. So going the other way, when current you writes code or documentation, take a few minutes to consider this. Will future you who has a completely different immediate context and working knowledge, be able to understand or follow your code when you see it again. One of the best ways to practice this is when you're adding logging to your code. Let's say we have a function, and it handles a request, and you've already thought through the ways in which your code could break, so you have this exception handler. But imagine how future you, so that's you a year from now, with no memory of writing this function or what it does or why, how would you understand a log message that looked like this? It's not that helpful. Wouldn't future you appreciate some hints as to why this function might have failed or what the parameters even mean? Think about what information future you would need to be able to trace and debug the issue as quickly as possible. Let's add some more verbose logging, some better error handling and messaging. Now when you see this stack trace, you've got actionable data. The same goes for documentation. Thinking of future you may help you write better docs. When I deploy a project or handle an incident or even run a so-called one-time script, I open up a text file and write down one line for every step that I just took, so that the next time I have to do this, I don't have to remember or relearn everything that needs to be done or its context. I almost always find myself, the next time I do this deployment, thinking past me. So thinking of future you as someone else you can empathize with is one baby step way to practice getting better at empathy. And in so doing, you will become a better software developer. But guess what? You can't practice empathy all by yourself. Empathy is by necessity a social reaction, so you depend on others to practice it. One step further than trying to put yourself in your own shoes would be to try to put yourself in another's shoes. And since it's easier to feel empathy for someone who is more similar to you, if you really want to level up on your empathy skills, you should try the following. During your next project, or even for just a day, make time to learn the job of a coworker who is not a fellow developer. Maybe join the QA team or the DevOps team to see the kinds of issues they face on their side of this project you're all working on. This will benefit you in several ways. First off, the more you work with someone, the more familiar they'll become to you, and the easier it'll be for you to start seeing what they see, feeling more empathy for them. You'll notice how the code you write affects those who are required to test your code or to make sure the serverless functions in the cloud running your code don't error out with mysterious bugs that wake people up at 3 in the morning. So then maybe you'll be more conscientious about updating the dependency list in the package you're about to deploy to prod. Or maybe you'll find and handle more edge cases because you'll have thought to ask the QA team what those might be before they get to work testing them. In the best case scenario, you'll ship your project more quickly because you'll have shortened the feedback and iteration cycle that you need to finish the product. As a bonus, you'll become more familiar to your coworkers, and it's more likely they'll come to feel more empathy for you. To generalize even further, you can improve your empathy skills by exercising something all the great developers I know have in spades, which is curiosity. Not just about other people, but about new projects, ideas, and experiences. The great developers I know constantly seek new things to try or novel ways to tackle a problem. We all naturally gather tons of experience as we progress through our careers, but seeking out different kinds of experiences and exploring new ideas will accelerate your progress exponentially because you can integrate your experience with a bunch of new perspectives. You'll also gain a wider view of the systems you build and work in as a whole. And, in some cases, by better understanding the problem and seeing a more complete picture, you might find that the best solution is actually to solve a completely different problem altogether. Some companies, like Google, already know the benefits of having engineers try on other hats. They have programs that let people do just that. But even if you don't work at Google, that doesn't mean you can't sit down next to a coworker to shadow them for a day, or even just have lunch with someone, just to get to know them a little better. Speaking of new experiences, another way to improve your empathy for other developers and your users is to read code written by others. You want to do this anyway, to deepen your understanding of the libraries or languages you work with. But another benefit is that you observe the great variety of ways a given problem might be solved. You might have an inkling of this from whenever you search the Python packaging index for a library. To use one very simplified comparison, If you work in Python and you want to store and retrieve data from a relational database, you'll come across the Django ORM and SQL Alchemy. Both libraries allow you to access data from a database, but one creates almost a direct one-to-one mapping between an object and a row from a database table using the active record pattern, while the other separates logic having to do with objects from the logic underpinning database operations using the unit of work pattern. As you look into these and the many other solutions that exist, they'll show you how the author of each library chose to make sense of this problem of data persistence. Maybe it'll present for you a new perspective that will help you find the right solution for your own problem. Or maybe you'll notice shared patterns in the way solutions are written by multiple developers, and you'll understand why these patterns exist. In both Django ORM and SQL Alchemy, retrieving the number of all the rows in a table is a method called named count, which is a lot like what you would write in raw SQL. So that would require less mental overhead for developers who are trying to learn either library. And that's what the famous principle of least astonishment is about. When designing a component, it should behave the way users expect it to behave. Well, to know how users might expect a component to behave, you need first to figure out who the users are, and then you need to see your component through their eyes. Building an interface in general is a really good exercise of cognitive empathy. When you write an API, you need to consider, who is a typical user of this API? What are the most common arguments that users will send over when they call your method? In what order are they likely to send them? In other words, what are your function's dependencies? Are there common default values for some of these arguments? When the user calls your endpoint, what do you think they'll expect to get back from it? What return type or response? I find tests really useful for figuring out how to build these layers of abstraction because your test cases are really just instances of a client using your function or your library. Let's say you have a brilliant new startup idea. It's OkCupid for dogs. So for your clients, you need to write a function to find a dog. So we have our test case, and let's think about how we want this function called findDogs to work by writing a test for it. So we most likely want to find a pet by relationship status, and we expect a JSON object with a list of dogs that match that status. So that means we want our function to get us a list of dogs. And to do this, it needs to make an API call. And now you have this function, but probably to call this API, you need some kind of authentication, right? So we're going to add some username and password parameters. And of course, now we have to change our test to add the same things. Okay. So now you have this function, and it gets you a list of dogs. But looking at this findDogs function again, doesn't that look kind of weird? Why does a function that's supposed to just find us some dogs need to know anything about a username or password? That's a hint that we should separate these bits out. But even if we find that findDogs should not accept a username and password specifically as parameters, the findDogs function does need access to them somehow. In other words, this username password authentication bit is a dependency of findDogs. Maybe we can encapsulate this username and password implementation into some sort of class, like the authDog API object, let's call it. And findDogs can now call this API object. Going back to our test, we now can fix our params. But to be honest, that looks a little strange still. Again, if I'm looking at a function called findDogs, I don't expect to need to pass in any kind of authDog thing, right? But what if I made a very small change? So instead of this, I could do something like this, and then maybe have a clearer name for it. Now this, to me as a user of this API client, it looks familiar and it makes sense to me. I hope I still feel this way, or future me still feels the same way a year from now. But with findDogs encapsulated this different way, I can see this component for what it is, which is an API client to get dogs. And that's what the client looks like. Malte Ubel, a developer who wrote a JavaScript framework that powers Google Photos, Google+, Google Drive, and some other very obscure, tiny websites, said this at a recent talk he gave at JSConf Australia. The way I would talk about myself as a senior engineer is that I'd say I know how I would solve this problem. The next level is that I can say, I know how others would solve this problem. And what this means, and this is Malte's conclusion as well, is that it takes both experience and empathy to create the right kinds of abstractions for your application. Now, you saw how cognitive empathy helps with naming things, which is one of the famous hardest problems in computer science. Clear, specific, and descriptive names make code more readable to other developers. And at certain scales, it's more important to write understandable code than it is to write performant code. Consider that a bug in your code may cost the company hundreds of dollars a month, but if it takes 2 developers 1 extra week to debug the problem because they had so much trouble understanding the code or what it did, that's thousands of dollars more. Similarly, an optimization you write for your program might save you thousands of dollars a year in CPU cycles saved. But if the code makes it risky to introduce changes, then those cost savings might just be wiped out by the development time required and the missed opportunities. So, software must be written not just for the computer executing your instructions, but also for the humans who need to maintain or change your code. Programming is really another form of communication, which is why cognitive empathy will help you become better at it. Another reason why empathy is crucial to effective communication is that it lets you establish grounding. Not to get too technical, but grounding is sort of the TCP handshake of human communication. It's a set of mutual assumptions, knowledge, and beliefs that get coordinated between you and the person you're talking to ensure both of you are on the same page. Establishing grounding can be as simple as nodding while you're listening to someone to signal that you follow what they're saying, or making a quick request for a clarification, like, huh? Most of us already practice grounding in everyday conversation. But one way to get better at grounding is to teach something to someone else. Imagine how you would explain to a 3-year-old why dinosaurs don't exist anymore. Now imagine how you'd explain the same thing to a 23-year-old. We intuitively know that for a young child, we might need to describe things more simply and at a higher level than for an adult. But it requires more effort for us to do this well when we're among adults. We all know someone who claims to love teaching but assumes we have base knowledge about the topic that we don't. This person will explain things in a way that goes right over our heads, or that's effectively meaningless to us. Or, on the other hand, they'll assume we know too little and waste a lot of time teaching us things that we already know. All they had to do was spend just a few minutes to check first that they understand what we actually knew, in order to do a much better job of teaching us something relevant and understandable. But even if teaching is not your thing, you can still practice grounding beyond everyday conversation. Let's say you're in a product meeting to go over some requirements. When it ends, take a few extra minutes to ask the other people in the meeting to describe the main takeaways from their points of view. If their main takeaways are different from yours, then you clearly require more grounding. The more you communicate, or even over-communicate, the more knowledge and context you'll share, and the more cognitive empathy you'll share. In fact, it's been theorized that empathy evolved for exactly this purpose, to improve coordination between members of a group so that they can respond more effectively to potential opportunities or threats. Context is also important because decisions are made under constraints, and sometimes we rush to judgment on decisions without seeing the bigger picture. So it's important to ask questions to fill in that context. Great developers don't hesitate to ask questions, even if it means admitting they don't know something. And one question that's very effective at gathering context is, why? Why did you pick this library over other libraries that might do the same thing? Why do we need to collect user data in this manner if there's an alternate way to get the same data? Why do you want this button to go here instead of over there? Now, why is an easy enough question to ask, but the hard part is actually listening to the answer. If you have a preconceived idea of what the other person is about to say, you might not actually listen to the answer because you're busy thinking up a response of your own. You'll talk right past each other. Active listening is making a conscious effort to give your full attention to the person speaking so that you hear and understand the complete message being conveyed. Listening is especially difficult if you're feeling angry or defensive, so it's especially important to practice active listening when you're feeling negative emotions. For example, if you hear criticism in a code review. One thing you could practice is active listening. Don't respond to the comment right away. First, stay silent. Suspend your judgment temporarily. Gather more information before responding by paraphrasing or asking follow-up questions to demonstrate you fully understand the other person's argument. There's a rule in communication theory called Miller's Law, and it's this. To understand what another person is saying, you must assume that it is true and try to imagine what it could be true of. Let's say a developer comes up to tell you that a library that you wrote is broken. Now, this might make you upset, and maybe you could ask them, why do you think my library sucks? But that puts them on the defensive. You're questioning their premise and implying the problem is with them. Alternatively, you might stop and think, okay, assume my library is broken. This person can't do their job. What are our options? You might ask them clarification questions. What are you using this API for? What is it lacking that you need? Could there be another way to get you what you need? By withholding judgment, you're showing that you're on their side. And by asking clarification questions, you're more likely to gain context for what they're actually trying to do. This is the goal of active listening, and it'll lead to your having more empathy for the person you're talking to. A friend of mine once asked me, do you know what you call someone who's always complaining about existing code being terrible all the time? And the answer was Junior. I think of this often. I remember earlier in my career when I would see something that we might derisively call legacy code, and I would judge whoever wrote it as maybe not that good at writing code. I'd spend a lot of time trying to refactor it, but what I didn't do so well was to invest time in understanding the code, to see why it might have been written the way it was. We could apply a version of Miller's Law to legacy code. When I find code that works but is unreadable to me, I first imagine that the developer who wrote it must have started out with good intentions and clear designs. I try to see what sorts of constraints existed that maybe haven't been documented so I can't see them, or what edge cases I haven't encountered that this code might be addressing. In other words, just because I couldn't easily understand the code doesn't mean that the code is bad or that the developer who wrote it was dumb. Now, to be clear, if the code is broken or buggy, judge away. But if the code's already in prod and it works, giving it the benefit of the doubt will help you resist the urge to refactor, which is good because refactors can become very difficult and costly, I can tell you. To sum it up, the purpose of developing software is to create things that other people want to use. The best software developers excel at this for several reasons. They understand what their users want, they write code efficiently and ship it on time, and they make it easier for those with whom they work to do their own jobs well so that the whole team can deliver a quality product. I hope I've convinced you that empathy is important for all of these and a worthwhile thing to practice. And here in convenient list form are the 5 exercises to help us become better at empathy. I hope this will help you to write better software, work better in teams, and give your career trajectory a boost. I would love to hear what you have to say, not in the Q&A, but outside in the hallway or on Twitter. You're free to contact me via email as well. My slides are posted on that link. And I want to thank a bunch of people who helped me to write this talk in one way or another, so here they are. And of course, I want to thank the whole Python community, and I want to thank you all for coming to my talk.